let's not go crazy. Let's not go crazy. Also, have my screen cropped off. That's pretty sick. That's pretty sick. Pretty sick. Okay. Here. Very nice. Very nice. Splendid, Ian. Let's turn down this aura music. It's too much aura for me for right now. Meow, 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 meow. And today is just gonna be a bug day. There's a bunch of bugs in the game. A lot of bugs. Not great. Kind of have a buggy software, so we're gonna see if we can't make this software a little less buggy, if you will. Should have gotten more water. Should have gotten more water. It's okay. It's okay. It's okay. We live. We live to see another day. And now we're in the process of making a large scale change that can break everything that's 2D animated, so that's pretty cool. Love that. Love to do it. Love to see it. It's fantastic. Love it. Love it. Okay, we're gonna bring this down a little bit. And yeah, we have this. It's not animating. We're gonna make it animated. I have a thing for animation, but it works for things that are not UI, and this is UI, so that's somehow kind of made things even more difficult. And then a quick hacky solution just kind of got ruled out because Unity doesn't let you derive from the renderer component, which is pretty cool, pretty rad. Love to see it. So instead of doing a cheap solution, we're gonna have to do the actual real-ish solution. So without further ado, I'm just gonna go through this and fix this crap. What do we got here? This is easy though. I think I already took care of some of it off stream. So I'm hoping this is gonna be largely simple. Largely simple, and it's just a matter of replacing text. This, honestly, what was it? GGVG. You can do this. I think it's %s. %s. Renderer.material. We're gonna replace it with _target material, and then just G. And I think that does it. Oh my goodness! Look at that. Vim knowledge. Vim knowledge. And then instead of render, I think what we're gonna do is do like, I don't know, material. Material. I'm a material girl. Okay. And then we're gonna do target material equals material. Oh my goodness, I suck at Vim. And that should be cool. And now we're here, and then we just gotta go here and change that to be shared material. Pretty cool. And then now I'm gonna make basically a clone of this. Literally just gonna be yoinking all that. CC sprite. Update render. We're just gonna that. Get rid of these guys. Oh my goodness, what am I doing? There we go. Everything's great. I love refactoring. It's my favorite thing ever. Why work on making the game when you can just make the code better? Unironically though, I do kind of like that. There's something nice to the fact that there's always some kind of technical tech to fix. So it's easy to fix a problem or a technical problem than to confront design decisions. At least that's for how it is for me. I don't know. There's definitely a lot of times where I just use technical issues to just justify procrastinating on design decisions because don't feel confident in terms of what I want to do. UI sprite render. It's not even a renderer technically. It's just like an updater or animator. In fact, I should probably name it to that, but whatever. Who cares? And you're gonna have require component type of sprite. I don't know, raw texture image. I think that's what we're doing. Yeah, I think that's what we're doing. Yeah, image. Okay. Unity UI image, yeah. Excuse me. Pardon me. I'm a little bit of a pig. You ever have like blood pressure that increases and you hear in your ear? It's kind of a rarity for me, but I just felt it right now. Kind of crazy. Kind of uncomfortable. Oh, we have terrible code. We'll fix it later. Render. Who cares? Like, who cares? Like, why do you even have to? Why do we do this? Why don't we just do a local variable here? Target. The render is kind of misleading. Just called target. What do we need here? And then we have to set the material. Because we're a material girl card target. Material. Not shared material, just material. And what else do we have here? What else do we have here? Is that it? Is that literally it? Is that truly all there is to this? Pretty nice. And then we go back to here, and then we go right here, and there's still a compile error. That's not good. Why is there a compile error? Oh. Because we changed the signature. Shared material. That should be it. That should be everything. I think. Hopefully. Nice. Okay. And now, what do we do? CC Sprite UI renderer. Get rid of this stupid mesh renderer component. We don't need you. Remove CC Sprite render. Yeah, I guess so. Guess we got. Oh, let's CC UI Sprite renderer. Yeah, and then we have this image here. Yeah. Remove component. Yeah. And then we have this, and it's gonna be SB dialog. Oh, come on. Allow me my arrow key. Okay. Anyways, we have that. Dialog progression icon. Raycast art. Yeah, I mean that doesn't matter, but cool. What else do we have going on here? I suppose that is all. I suppose. So if that's the case. See, it doesn't even have a render dependency. They just need the material. Honestly, like, oh, whatever, who cares? It's fine. It's fine. We're just gonna play. Hopefully everything works exactly as I intended it to work. If not, I'm gonna be very mad. Okay. Buddy oh pal. Yes. Little crack addict. Let's just keep going. Yes! It's animated. The little icon at the bottom. All this work just to make that happen. It shouldn't be this hard. It really shouldn't require this much effort. It's not even that much effort. It's like what, 10 minutes, 20 minutes? Still, it shouldn't have required that. It should have been just available out the box. Nice. 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 Alright, cool. Cool. Very nice. Very happy with that. I feel like I need some more water, honestly. Anywho. So cool that we have that fixed now. That's pretty rad. Things I need to work on. We have better shadows. I don't know if you can tell. But yeah, the shadows are much darker now. They're actually at their true shadow valley, which is pretty cool. So now we have things that feels far more dynamic, far more sharper. It's very nice. Ah! In fact, 1 second. Yeah, so things, it just feels like such a stark difference. So much more ambiance. So much more ambient. Like here, look how this feels, man. Just stark difference in lighting. Lighting just changes everything. One thing I do need to do though is add some. I had point light supports. I got rid of it just to test this feature or test this new revised light model. I need to reintroduce it. Part of what I'm gonna do is also add radius to it. I think we only had like a luminance thing, but oh yeah, death is back here again. But yeah, we kind of need to have some lighting, don't we? Lighting's point or spotlight, not spotlights. Point lights are kind of important. So I suppose we can do that. Let's just first get this applied to our prefabs first and foremost, because now that we have it working the way we desire it to, I'd rather not have a break on future endeavors. Material texture property. Main text has a offset scale set to it. It is compatible with the sprite. I don't care. We're not using the. Are we using the sprite? What are we using the sprite render? Wait. Copy component. Get rid of this. Remove. We should not be using the sprite render. I think we should only be using these two things. Let me test it out again. Make sure I'm not full of bologna. Okay, you're back here. Yes, sir. Dash. Gore. Ooh. Almost messed that up. Okay. Okay, so it works without the sprite render. Okay, so we can get rid of it. Apply to prefab, apply to prefab, get rid of this to prefab. Very nice. Nice. And cool. Save. Let's even friggin' commit it. Let's just commit it. Let's commit to the bit. Where's our here we go. Oh, that's a lot of changes. What is these changes? What? Animated material, yeah. Demo sprite, yeah. This checks out. All the materials change. Okay. That. Why would they change? T trash bag idle dot mat one. Okay. I guess because uniform data change. I don't know. Progression icon. Either way. Added progression. Added text progression icon and Riva and UI animated sprite. Support. Oh my goodness. Push origin. Okay, and then CC, MMCC DK. changes there. Yeah, minor light model stuff. I'm gonna do some more things with it though, so I'm not gonna stress about it. And then, yeah, okay, so it should be pushed. So now let's go through our little implementation of our point lights. Because right now I believe our light model is not supporting any point lights. So let's just do that. It's called cozy light settings, I believe. Yeah, that's the guy. That's the Jiffy. So we're gonna do some little extensions. We're gonna have another point radius. What is the plural of radius? 1 second. I'm curious. I'm curious about this. What is the plural of radius? Radii? Like... Oh yeah, so radii is actually valid. That's just real. That's, you could just say that, and that's perfectly fine. That is odd. Oh my goodness, I almost fell over. I'm trying to crack my back real quick. Oh, that feels great. That feels good. That feels fantastic. Okay. So now that we have that settled. Now that we have that settled, let's actually name this radii, because I think that sounds cool. Radii. Point light buffer size, yes sir. We allocate that. Okay, point light config. You're just gonna have a little bit more information tied to you. Yeah. Radius. In meters. Though I suppose it doesn't really matter, it's just radius, but whatever. Specificity doesn't hurt. Unless you're specifying the wrong thing, in which case that's very harmful. But it is okay. Okay, and then we have light config, RGB. Cool, let's move this a little bit so you can see some of what I'm doing here. I know I'm not very super helpful on that, but or super accommodating when it comes to showing code. But I at least like to pretend. Okay, let me make sure this is fine. Okay, this cool. So let's actually set up our environment too while we're at it, so we can test this point light thing. Where is the player? Where is the player? Hierarchy. Why did that organize you so bad? So bad. There we go. It's right next. It's right in front of me. Okay, cool. So we have the player. Very nice. Let's say hi, and let's find light source. We're gonna make a new point light. Nice. I have it over there. Let's bring it over here. And currently, I think the player per vertex shader should respond to the point lighting, I believe. I'm not sure. Yeah, the per vertex lighting is kind of responding to it. That's not right. Okay, we have work to do. We have work to do to make this lighting great. It's okay. Cool, so we have our scene set up. Let's turn off the gizmos too while we're at it. Oh, actually, we kind of need to see it. Alright. Let's start attacking this. It's going to be a two-pronged thing. the prong numero uno is making the CPU side kind of have the data accessible, which we already kind of started. So you can see here we have this radius parameter defined for this light source, which is cool, which is pretty rad. Yeah, and actually probably have that tied to the sphere we're currently drawing. So instead of using draw a wire sphere, light config intensity, we're going to use radius instead. And that should respond accordingly. Oh yeah, so that's the first prong, and the second prong is going to be going to our light model shader and then updating that to work appropriately. That should also be very easy because the code's already there. It's just modifying it a little bit. We'll see though, because I saw some funky stuff where like this cuts to the shadow, but you're not seeing the color, the base color work on it. So that's a little concerning. I feel a little scared, but we're not going to worry about that. We're just going to assume everything is going to turn out for the best. Anywho, so yeah, we have this. We have this light config information, which I believe that's what you're modifying. Yep, that's what you're doing. And then we have our update method. Cool, we have to update this stuff here. So okay, this should be pretty straightforward, I think. Radii sounds so cool. It's going to equal to config dot radius meters. Very cool. And then what's the next thing we got to do here? Point lights. Yep. Just have to modify this guy. Actually, we have to modify this one. Also, why did I not cache this? Why am I so bad? Why am I a bad guy? And then this property is going to be, I don't know. What's our naming convention we got going on here? Point intensities. Point radii. Very nice. Okay, we can go back down here. Modify this guy. And then, nice. Cool. Easy as can be. And I think that should largely cover all the CPU code, if I'm not mistaken. There's update, there's unregister, there's register. Register also has to be tackled as well, but that's also easy. Cool. I think that's about it for this stuff. And now we can go into the lion's den and see the monsters we have created for ourselves. So first we have to update. We have to add, what are we doing? We have to add a new variable here because we now have this new array of properties. Nothing crazy. So we have that. We defined, so we said, hey, global shaders, we're gonna have this new array of variables concerning the radius of our point lights. Sick. Okay. So where do we go from there? We have to go down to our light models. So a little refresher, we have two light models. We have a per vertex and per pixel. So let this joint recompile real quick. And we can take a look at it. So I go here and I go to this material. I'm gonna toggle the two light models. So you have one that's kind of executing this like shadow check on every pixel or every fragment. And then we have this other one where it's actually doing it only on the vertices, which is kind of an artifact or something you would see in like N64 type games. From back in the day, it was more performant, man. And I think it just looks kind of cool. So that means we have two different ways of integrating this light model. One for the per vertex and one for the per pixel, but it's kind of simple. It's not that crazy, because I think I've largely centralized them all into one place. So let's take a look. Let's take a little gander into our light model here. And I think we even have just one method to handle this point lights. Yep, here we go. Here we go. And I think we're even doing some of this filtering already, where we go, hey, if the distance is greater than 20, you're not going to be lit because it's too far away. But that's an arbitrary number. Now we actually have a real number to compare, which is radii. So now we can go, oh, okay, if the distance between this pixel that needs to be lit and this point light source is greater than the defined radius for this point, we don't light it. It's out. Get out of here. We continue on with our day. So that's one step. That's done and easy. Next thing is we have to do averaging. So we have like these two variables that we're modifying for all the lights, and it's kind of being passed. These two variables are passed down this pipeline, where you modify them for all the point lights, and then you modify them for the sun and the cache data that's done from it. Basically, one is just the sum of all the luminances, like all the light sources, and the other one is the color composite. And adds all the colors that are currently being lit. The final step, though, is to divide it, and we haven't kept track of all the different light sources that we actually are factoring into the final light source. So we got to add that. Int, I don't know what to call this. Total, I suppose. Total light sources that are factored into this. Yeah, that sounds about right. Yeah, that sounds about right to me. And then we have this light model here. So we have to modify this in, or do we? Do we have to factor this in, actually? I don't think so. Yeah, I don't believe so. Okay, cool. So we actually keep this outside of that method. Very nice. So point light, in out, int total. We do stuff here. We can do total plus plus, call it a day. And then is hit by sun, that's a different thing. And then we have the sunlight process here. Actually, we can get rid of this method. And total. Hopefully this is pretty simple. And here we just increment it. Cool, and then all usages of this are going to be bad, but it's fine, we'll fix it. I also commented out the point light processing, so we can add that back here again. Total lights, let's say. And we're going to initialize this bad boy to 0. And then we're just going to pass it in here. Okay, and then finally, what do we do? I forgot why we did this. What was the point of this? Oh, this has to be passed in here. Oh, this is not gonna be as simple as I wanted to, because we might have to modify a bunch of shaders. Oh no, that's not great. Yeah, because we have this V2FI structure that we have to go modify for them. That hurts. And I don't think... like there's just one of them, but there's a bunch of these. Yeah. Is there anything we can pack to have this information? Like light colors for... You know, honestly, What I might do is, because this is only storing color information, so we can just, but alpha doesn't matter. So I can just use the alpha channel and the light color to store this information. Kind of jank, but I don't have to modify stuff. I think I'd rather do that, honestly. Light color. Oh, actually, no, we don't have to do that because we were passing this data here. Light composite divided by total count, total lights, yeah. Yeah, that's what we needed to do it, use it for. It was the final average for the colors there. Yeah, okay, never mind. We're good. We're good, I think. Maybe for the pixel lighting, it might be weird. We'll see. Light color. Oh, it's actually not going to be that weird, I don't think. Yeah, no. It's just all done within a single pass. Yeah, okay, never mind. Or within the single stage. Okay. This is actually surprisingly pleasant. I'm not sad or mad or angry. This is just working. Oh, this is beautiful. This is fantastic. And then light colors can be divided by total. Okay. And did we make things worse? I think we did. I think things are looking a little worse here, pal. Yeah, that looks like crap. Oh, fantastic. That's my favorite. Okay, we can see how it's interacting with the shadows, though. That's kind of cool. It's not doing the lighting that I wanted, though. That's not cool. Not even seeing that color being there. Okay. Sweet, so we've caused fun new damage in unexpected ways. That's so weird because this is the highlight. The areas that would be light are dark right now. Over here, you see in the highlight, it's fine. Yeah, it's doing thing. It's doing a thing. I don't know why those things are lit, but hey, that's kind of cool. So there's something weird with how this is kind of being composited with our cast shadows. Noted. Any issues here? Oh, that's just weird. That's just odd. Yoko, oh no. Okay. That is in the per pixel. Okay, what's going on here? What's going on here? What are we doing? What is wrong here? What have I missed? What sauce have I lost? Average. Wait, what are we using? Wait, what? Okay, that fixed that issue. There's a weird term I was adding for no reason. So okay, that's a win. I'll take that W. The question is, what is this shadow that's being casted by this light source? That is a very big question mark for me. Why in the per vertex lighting are we getting this, and why in... Oh, it also happens in per pixel, so it's something that's unified about both of them. Fun. Very cool. I don't know what to make of that. I guess we can get rid of average. I know it fixed the issue for something, but I forgot what the issue was, so until that issue comes back again, we'll just ignore that term. Lerp luminance, a refresher, 0 is shadow, 0.5 is the base albedo. Times light color. 1 second. I'm not doing that. I'm doing like 1, 0 is shadow, and 1 is the albedo times the light color. So the light color is gonna mask the base albedo color. Okay, maybe clamp as well to be safe, to make sure they're all within valid range. That shouldn't impact anything, but it doesn't hurt to. Wow. Wow. That became really. Wow. That's kind of cool. Wrong, but cool. Okay. Never mind. How about we just focus on this one broken thing at a time? Let's focus on that. Let's increase the radius too, so we can see it, the shadow cast. So what could cause this? What could cause this? I could see a scenario where the composite light color equates to 0, and when we use the lights, the color lights, when we do the final composite, even though it's not using the shadow color anymore, the color is actually going to be just pure black. So, okay, if that's the case, how and where does this light composite equate to 0? Well, it can equate to 0 if we set it here to 0 initially, and none of these increment the light composite value. That would be the case. That would be what causes that. Where we have this and that, intensity, point luminance, point color composite. Color composite, yeah. In, out, float 4, yeah. And we go here, and for whatever reason, something's going on. Wait, what am I? Why are we doing double? Why are we multiplying by intensity twice? Why are we multiplying by intensity at all? I think what? Was I high? Like, okay, there we go. There we go. Like that's the thing. The color is significantly darker now though. But I think it's because we're multiplying the... Oh, intensity doesn't affect things at all, does it? Interesting. Why did we do this? Color, oh, because the color... Intensity has to affect the color. It determines the weight of it. Oh, okay. Still a little confused though. Still a little confused because now it's cutting through the shadow, which is fine, but we're not getting that blue color, that patented blue color, which we so enjoyed, or at least I enjoyed. Yeah, very odd. I love this vertex, like. This is a cool thing about vertex lighting, because you see the lights kind of snap in at like these increments. I find it to be very cool. I guess if you're making a AAA game, that's kind of unacceptable. Someone's gonna write an article, or talking about is gonna write an article about how bad your game is and how lazy the developers are. But for this application, I think it's pretty neat. I think it's pretty sick. But yeah, we need this blue base color to be happening here. So we have to think about how we're doing this color composite. Because we're going to every single light source, adding the base color, plus its intensity, like a weight. How do we do this? Is this going to affect it uniformly? That's a question. Color plus equal. It's so interesting. And then we have this remap invert, which is also a weird. What does remap do? Remap invert facing light, away from light. Zero's away, so okay. Why do we do that? Well, I guess we... I'm lost in my sauce. I did something. I cooked at some point. I thought I cooked. And now I'm back in the kitchen the next day and I'm just not understanding why we put oregano in the Pop-Tart recipe. Aggregate color times intensity. What are these values we're working with? Value remap. Why are we doing this inversion in the first place? Because this value is going to be from, is going from -1 to, a value range from -1 to 1 to -1 being, wait, what? 1 second. Okay, -1 becomes 1, 0, 0.5, and 0, 0. Okay, yeah, so it scales it down by half, and yeah, okay. I'm saying okay, but I don't actually. Okay, and I understand. Okay, so this is for the initial change right here. And then this goes, inverts it. Okay. So we don't even need this remap inversion. Because value remap alone is good enough. Like, that's not a thing we need. Okay. So if we come to that conclusion, yeah, the big thing here is how we're going to factor in individual light source color intensity. We can apply the color evenly, but we have very little control over intensity, how present they are. And multiplying by intensity was like a simple solution to achieve that. But we're losing some of the colors here. Oh, you know what? I think I'm starting to understand this. Yeah, and I'm understanding this. Because sure, you have this color and you have its base intensity, but if it's not facing the light source, it should not be factored into. It should not be factored into the color aggregation. But that's what's causing this. Okay. We could do this, but we're losing the blue characteristic, and that's a problem. Also, intensity's not really affecting this very much, which is kind of interesting and also kind of problematic. Maybe we just say screw it. No, not screw it. I want my colors. I like pretty colors. I like them a lot. It's gonna be a load of malarkey. We can't have them colors. Boy, also, what is this going on here? Do you see this? A quarter of the circle is gone. The higher up it goes. That's odd. I guess because the face is facing away. There's something weird going on there when the face is going away from it. I don't know what it is. It makes me uncomfortable. It means there's something wrong that I've neglected, which is not a first, but usually I like to at least be aware of what I'm neglecting. It's like saying like one of the houses in your neighborhood has a gas line leak. Like, it's good that you know that, but which house is it? Okay. Where does this leave us? Where does this leave us? Nani? 10 p.m. My phone screen goes to black and white. But I don't think that really helps when I'm still staring at a large number of displays with vivacious colors. And intensity isn't even factoring it. This is so weird. What was I thinking? What was the thought process here? With this remap inversion. So we do the remap inversion, what ends up happening? 1 equals away from light. And then 0 equals facing light. So how does that factor in here? Ideally, honestly, no. This actually makes sense. Facing light. 1 should be facing light. 0 is not facing light. Okay, I understand why I did the remap invert, because ideally, if this is not facing the light, we don't even want to factor in this color into our color aggregate, right? We don't want to do that. So if the normal or whatever, because that's what this is representing, is how aligned is the surface of this material to the light source. If the normal of it is facing away, or aka it shouldn't be lit, we shouldn't include this into this calculation of aggregate colors. It simply should not be factored into it. However, okay, this is the crux of the issue. So we have this value that says, hey, we're either gonna add this color to be weighted against the color aggregate or not, right? But then beforehand, earlier today, we added the whole, hey, we're gonna count how many light sources are factoring into this. So you can have a summation of, let's say, 2 colors really, because a third color is in the shadow for whatever reason. But instead of dividing them by 2 to get the average, you're still dividing them by 3, because technically there is a third light source that's somehow being factored. And because of that, oh, that's exactly what's happening. Because of that, we're having a far lower color value. And that's what's screwing stuff up. That's my hypothesis. But let's actually validate this and see where we're doing this color at total addition. And it's got to be happening in the point light process. So what do we have here? We have point light process, yada yada yada. We iterate through the point lights. If it's not living, we skip it. If it is greater than the radii, we skip it. Yeah, that's got to be what's happening here. And then only here, we're just adding it, regardless of the value of like whether or not it's facing or away. And that's what's caused. I think that's what's causing it. So what do we do? What is a gamer boy to do here? We can do plus equal value times, yeah, just value. Because we can't just do like a 0, 1, because there might be like, I guess we could do round or yeah. Because like, if you look at a normal, the dot product range is, there's a bunch of range that's not going to be perfectly aligned with the direction. Like you have your light source that's coming from here and your surface is facing this way, and there's like a range where even when it's not perfectly facing it, or even like over here where it's not really super bright, but it's still going to be affected by the color light source. So I guess we can do ceiling, where if it's above 0, we just round up to 1. And anything else is just gonna be 0. And we just add that. That could be the thing, or floor. I forgot. Is it ceiling, floor? I think floor. Yeah, that didn't solve. It kind of solved it actually. You can see the color actually being factored in here now. That's kind of cool. But maybe we're not using the right function. We're just trying different stuff and see what happens. Interesting. What is that artifact? Very cool, but also not cool. Okay, then let's do a condition. Let's do an explicit conditional, and then just have it be like an int. I think you can do that, right? You can just do. I know you can do that with floats. I never did it with inputs, so it should be the same thing. I think. Do you just cast it actually? I think you just do that, where you can just do value less than 0 or some other value range, and that can. Yeah. Okay, out of curiosity, let's just do value. What do we get? No, we get some weird stuff. Okay, so I'm liking the results from this. I think maybe we gotta reduce our. Shouldn't this be the other way around? Shouldn't this be the point of like most lightness, and then this be the. Is intensity affecting anything at all? I'm not seeing that much change in intensity. This is very okay. We're getting somewhere though. We're getting somewhere. What if I do the opposite? No. Okay, let's shift this down. Let's do like -0.5. It's like a 45-degree angle from. Okay, this is not behaving at all like I want it to. Okay, let's rethink this. Let's think this. Let's just big brain time. We have the direction. We're doing a dot product between the direction and the world normal of the surface. Very cool. And direction's what? Point positions minus world position. So the position of the world here. So they're gonna be inverse of each other actually. They're gonna be pointing against each other. So really, value should be like negative. That's weird. Oh, this is integer value. Oh, maybe I should do the division with the integer instead of or a float instead of an integer. Now that I think about it, that might actually be better, because then we can have more nuanced value ranges in division, which may be of benefit to us. Let's actually try this out. No, we're not gonna get any errors because it's kind of saying, hey dude, it's all gravy, baby. I don't care, you can give me an integer and I'll just cast a float automatically for you, which is convenient a lot of times, but also in this case maybe not so convenient because it doesn't make it very clear where our changes are happening. Light total. Yeah, here we go. This first one, float. That's one. The next one is gonna be the per vertex. Yeah. Yup. Right here. Okay. Almost. Okay, going back to our totals thing. What do we have going on for us here? That's for the sun light processing. That's fine. We can assume that there's always a sun for our game. That's always gonna be the case. What about the point light process though? That's the real thing. Okay, that's better now. Actually better. Significantly better. Still a little jank. Still a little jank, but this is better. This is good. This is very good. And intensity. See, the intensity is not affecting anything. That's the thing that's killing me here. I don't understand it. We're multiplying color by the intensity, and we're in scenarios where remap unless the remap invert is, but even if it's like a fixed, like it's a fixed value, how is this not affecting anything? It's just not maybe. Execute in edit mode, so it should be updating. Point radii, point intensities. Okay, crazy idea or theory. What if our intensities is not named correctly? Point intensities. That'd be weird, but intensities. Yeah, no, it's fine. They're named correctly. Update point light. Yeah, these things are correct. Dude, this kind of sucks. Okay. Hold on. It's almost working. You can kind of see it almost working. It's like trying to work, but it's not quite. It's what is going on here, dog? Help me out. Okay, what if we make the radius bigger? It's not affecting anything. Okay, let's just go back to what we did before, which is it's weird that intensity really isn't impacting anything on this. That's so odd. That's incredibly odd. Remap, inverts. Oh yeah, this was fine actually. Okay, this is kind of working actually. Still weird that intensity is not having any effect. I really am struggling with this. This is very weird. I'm struggling to understand why this is not like, unless this is passing like the wrong, like maybe I have the wrong data types. Like I just thought I did the right thing, but it turns out I didn't. Let's see here. Point lights, set float array, Point living, point, yeah, shader, dot set global float array, point radii, point radii. They're both float arrays. Point intensity, point intensities, point radii. Yeah, this is very weird. Unless intensity. And this is the new thing we added. And it seems to be working fine. Yeah, it's super... This is very intriguing. I wonder, okay, let me try disabling and re-enabling this. That's so... So this is actually working, kind of. It's just that, yeah, like you can see the color come in. It's just... That's crazy. And then, yeah, Radius is responding properly. The only thing that isn't is intensity. Can I make this a slider? Like, I keep doing negative range and I don't want that. Yeah, let me just configure that just for ease of use. Zero, I don't know, it's like 10 or 100 for, yeah, 50 for debug purposes. I don't think I need to do anything beyond that. Like, this should be more than enough. And I'm seeing like no visible change. I can change the color, and the whole thing's affected by that. Is there like a reason? Did I really have to do like intensity squared? Is that what just happened? Like I just had it right the first time and I just didn't understand it. Nor will I in my infinite knowledge. I can't. Let's just do it. We have nothing to lose, right? City. And that makes it even darker. So that's odd. Like even with a really relatively low value, that is strange. What am I passing in for intensity actually? Let's take a look at this in point light process. Where is this value coming from? Ah, haha. Oh my goodness. That's the issue. We have this value. We're not factoring the actual value from the Oh my goodness. There we go. There we go. Now I don't like this whole thing that we got going on there. That's a little weird. This darkness that's surrounding it. That's not good. But this is progress. his progress. Lower his this though. We don't have to do intensity squared. That's unnecessary. No need for that. This is interesting though, because where's our valley map? Is it by sun? Here we go. What if I just go back to 1? We're gonna have the same issue again. No, we're not gonna have the same issue. Or still like the same kind of behavior. Oh, what is that? What is that? Okay, then you have these weird spirals that emerge. What is this? That's kind of cool. It's like a super. It feels like a fabric surface almost. That's really cool. Yeah, I'm trying to figure out how to do this color compositing stuff better though. I know it's commutative multiplication and division, but at the same time, I don't really trust it. I like being explicit in my order of operations, but this is fine for now. This is fine for now. Okay. So I can just do like, hey, is it at least positive? The 0 inclusion makes a big difference. I just wish that if it's like, because it is normal, so I guess maybe this value shouldn't even be about, I feel like I need an aggregate between value and intensity. Like if intensity is over a certain threshold, because we have like this, there's like two conditions. There's the value itself, where it's in this case greater than 0, or greater than or equal to 0, times intensity also greater than or equal to 0. So many parentheses and all of them are necessary. I think. Yeah, like. This is such a weird effect. What is this? Do they have to have the same limit? No. So this condition of whether or not it gets added into this thing. So what do we have here? P distance is gonna approach 1. incrementally. Like, that's just what's going to be happening. Distance, p-distance, and intensities, they're all going to be positive value things. So this inherently just goes from a value range of 0, or a very small 0 value, or near 0 value, to almost 1, or near 1. So those are always going to be positive. Same thing with value. It's normalized, which means that the magnitude, the ultimate value is going to be between -1 and 1. So I guess what we can do is do a clamp 0, 1 and do value times intensity. And that will be the indicator. Gosh, I wish I could have this be closer to you. Because it's almost like this is the only light source. And it blends with other light sources fine, like other point lights. It actually interacts with each other very well. It's just that the issue is that the shadow stuff is weird. Like the cast shadow things, it doesn't interact very well with each other. Well, it can, because it does pretty well with the per vertex lighting stuff. Just not very good in the per pixel category. It kind of just seeks to be in full control all the time, which I don't know why this per vertex thing is. I guess it's not doing it perfectly. It's just that the artifact is not as noticeable in the per vertex because it's right at the very edge and it's blended out like crazy. Whereas you notice it very discreetly here. So what does this mean for us? It probably means our compositing, the way we're compositing this stuff isn't perfect. That's supposed to be green, man. I don't see no green. That's kind of green, greenish. I don't know. It's kind of cool though, because we can have a spotlight effect, where like everything within this range is just purely lit strongly, but everything outside of it is not, which is pretty cool. And that's not something you can actually get with like built-in Unity spotlights or point lights. They're usually very enforced, that kind of softness. But here I can be like, nope. It's gonna be very strong here, very strong. I like that. Let's make this 100 to be even more goofy. Now it just feels like a portal, dude. Yeah, does this even get added onto? I think it's part of the issue is that this is being included into it. How do we exclude this? Clamp 0, 1, value times intensity. If intensity is like 0 and value is negative. We should have like a discrimination zone. Negative point, like 0.01. What does that do? Yeah, you're still gonna have that issue where it's like could we even just exclude this from the light model? Like if it's If statements and shader code bad, but honestly, I just kind of want to have this branching. Like, hey, if oh, it's gonna be like different results per. Oh, whatever. I don't think branching is that big of an issue here. If value times intensity are greater than 0.01, then we do total plus. And we do light model. Nice. I don't like the edges though. I don't like the edges. So what can we do? Can we do like a greater buffer? Really? That's like having no impact at all? I can like smooth this out, but not happy with it. I guess over here, like in the per vertex line, it's fine. But it's something we have to address if you want to do more extensive things with this. Go. Also, there's this issue here too, where sometimes like this is like cuts off here prematurely. I don't know why. We can figure this out though. Dude, it's kind of cool to play with this though. Not gonna lie, this is super fun actually. Feels almost eerie. It's like a crash landing zone or something. Like, yeah, I need to figure out something better for blending though. That's a must. I don't know. Maybe we just do get rid of this branching thing and I don't know. We're adding the color one way or another. Remap is what? Oh yeah, there's something to this too, where is lit. Yeah, we have this is lit value that we're using. I mean, we're just using value as well to determine if something is lit. And what are we using for this again? We're using value. We're just using the dot product? Is that all we're using for the is lit? We're not even factoring this within the I guess it doesn't matter though. Yeah, because we're not doing cache out of dot for, yeah. Value normalized dot, direction, world normal. Normalized dot. And we're using this value to determine if something is, if it's lit or not. I guess. And it's a negative, it's a 1 to -1 range, yeah. So I guess we can do intensity. I think that's what let's actually do that. This might be what we do, is float is lit equals value times intensity times 2 minus 1, and we're going to use that instead. Okay, that's actually, it's slightly better actually. That's actually really good. This actually feels better in determining whether or not this is yeah. Okay, we're getting better. And then I think now we can just use this instead of total, we do use this is lit value instead. And now the summation should be a little bit smoother, I think. It is a float. We have to normalize it. Okay, yeah. We have to, because right now it's in a -1 to 1 range. So we need to multiply this by 0.5. Minus 0.5. Okay, we're getting there. -1 and 1. Plus. Okay. What do you think? Times 2, so it's from 0 to 1. You could go to 0 to 2 now. Bring it down to -1. And then in this total, we do the opposite. We do is lit times 0.5, so it'll be a range of -0.5 to 0.5, and then we increase it by 0.5, so now it'll be in a range of 0 to 1, which is what we need for this total summation value, which is going to indicate how this is added on to stuff. It's not perfect though. There's still noticeable transparency that you see there. No, I'm not gonna rename it. Intensity times 2. Yeah, because intensity is going to be inherently 0 to 1. It approaches 0, the bigger the value is, and it approaches 1. Okay. sure what to do here. Aside from just multiplying, because this is making it better. It seems like. Yeah, like that. That makes it seem less harsh. Okay. Not there. Not to that degree. I guess with increased intensity, we can break stuff. Oh. That's really cool, but wrong. But really cool. Let's make sure we clamp this. Yeah. Yeah, so don't get some weird stuff like this. So you can do cool stuff with this. Like, you can paint shadows. I know that's not the intention, but it's cool that you can do that. I don't understand this though. Why this cut off here? Like, that's like, I don't know. Something weird with the... Because it's pretty consistent anywhere this moves. So what? The normal... What impacts this? What sets this range? Because it should be, like this side here, it should be lit, but it's not. And I don't think it has to do with the fact that it's intersecting another... Because it's not even intersecting this light range. So it's not that. There's something about surfaces on the ZX plane that cause this, and I would likely venture to guess that this is a dot product thing. The thing is that the dot product is still positive, so I'm not sure why this would be an issue. I really don't know, unless like my calculation is just wrong somewhere. Where is it per pixel? Lighting, there we go. World position. The world yeah, it really depends on the... The only thing that can affect it is a normal map, but there's no normal map on these textures, so... And it behaves fine in other contexts. It's like, I don't understand why that's the case here. I want to add something here to warrant having this light source though, because it's pretty cool. I'm not gonna lie. It is pretty cool. I can't deny it. If I leave this here and let's press play, let's see how this looks. Yeah, that's pretty sick. That is super cool. Yeah, look at like... That's super cool. I love that. Oh no, I fell down. And now we have to make the light sources brighter because there's no more, they're not squared anymore. So the sun has to be brighter again. Let's do that real quick. Nice, the way it's supposed to be. Yes. It's a little too bright actually. Down a notch, yeah. Nice. I need to figure out what I'm gonna put in the water there. Just to add that intrigue. And that looks so cool. That looks so freaking cool. I feel like we have to make the normals a little bit more extreme here. I don't know, where's the light model? Yeah, what do we do here? How do we do this? We do... Where do we calculate that? Yeah, here we go. So we just do a division. I don't like that. We have world normal, which is equal to the, yeah, the normal map one. Let's do this instead. And then we're gonna have like a value, normal map weight, and weight, which is a float. And you can say like, I don't know, 0.8, and this will be multiplied by n weight, no, times n weight, and this would be multiplied by the inverse of that. Times 1 minus n weight. Pretty sick. Still not that much. Let's make it even higher. Ah, my hands are... Okay, this is wrong. Like this is correct. But the fact that it's like it requires a kind of drastic measure before it gets recognized. Or maybe it doesn't. Maybe I'm just being picky for no reason, but yeah, like here, you're not seeing that at all. Like there's no lighting happening here whatsoever. We gotta be at a slight angle, but like look at that, there's nothing. That's not right. impacting anything. That's not having no impact at all. World's normal. Object to world normal. So you have the normal of the face, and then we have this vector offset based off the normal, but not quite. New norm is this. Dot product I world. Yeah, the object normal, yeah. Honestly, it doesn't even need to be this. It can just be that. Dot Z. And then we could just reduce it by like 0.5 or 0.2 or something like that. It's like having not that much effect. It's kind of having effect, but it's not quite there. I also don't know why it does this blocky, like, chunk in thing. I don't know why, that kind of bothers me. Honestly, this could just be this, and it wouldn't, like, you can set it to 0 and it'd be the same effect. Honestly. Like, I'm seeing very little change, if any at all. Which kind of sucks. So you have much to figure out here still. Yeah, I need to figure out this normal map stuff a bit more. Her face is messed up a little bit. Ain't it? There's something to this, actually. Did that fix things? Did inverting the Z direction actually... It feels like the normal looks better. Like here, no, it should be much... It should be way more affected. I don't know why it's not. This looks so good, man. This actually looks so good. It feels like a fire room or boiler or something. Like it makes you want to make a level with that. It looks super duper good. Oh yeah, we're gonna do something with this. Oh. Yeah, I need to detail this more, play around with this more. I hate that it's like either or, it's not like a gradient. That's the thing that sucks about this. TextCD bump.uv. Kisa could. Let me actually do something. Can you? And there's the end normal map for lady, player, idle up, run left, right, up, idle down. Here we go. No, that's running down. Where's idle? Why is this called idle run? It's just run. I'm sorry, what? That's for attack. That's for running. What are we talking about here? Does the player not have idle normals? That'd be weird. Or is it just not called that? Did I just break naming conventions for that in particular? Oh, I called them normal. Like a jabron. We did point and no filter. Let me try bilinear filtering. And see if that affects anything. Okay, so filtering on normals is actually kind of nice. Because you get this here. But if I were to... You see how it kind of fades in more smoothly? Still has the blocky thing though. I don't get that. I don't know why we have the blocky thing and not just a gradient value. It's like an either or thing. That I don't quite get. More stuff to figure out. I don't know. Okay, I think I'll call it here for today. We got some stuff done. I wanted to do some audio work today too, but getting lighting, point lighting work is good. $10:59, yeah. I'll call it here. Thanks for watching. Have a good one.